Okay, so elements are arranged in the periodic table based by increasing number of protons. The atomic number of each element tells us the number of protons. So hydrogen has 1, helium has 2, etc., etc. If we're to look at an atom, those big poofy shapes are electrons. So they're electron clouds. They have a negative charge and they take up most of the space. So they occupy most of the volume when we're looking at how big an atom is, but they're not very heavy. They're less than 2,000 times lighter than our neutrons and protons. Inside of our atom, in the very center, we have our nucleus. It's made out of protons and neutrons. It has a positive charge. However, it does not take up that much space. So we say it has a negligible volume, but it takes up most of the mass. So most of our mass in our atom is due to the protons and neutrons. When we're talking about protons and neutrons together, we can refer to them as nucleons. Now, sometimes we don't want to draw out all of the protons, neutrons, and electrons. We use the atomic symbol. In the center, we have a symbol for our element, and then on each corner, there's various meanings depending on what's in each corner. So either at the bottom or the top left, we usually have the atomic number, which is the number of protons. This number is usually omitted because it's constant for each element. So it's like the identity of the element. So carbon always has 6 protons. Hydrogen always has 1 proton, so we sometimes don't write it. On the left of the larger number will always be the mass number. So that'll be the number of nucleons we have in our particular element. That does change, so we do usually write this. At the top right, we usually have the charge of an element, so whether it's positive or negative, whether it's a cation or anion. And this is when we've either lost or gained electrons. At the very bottom, there's sometimes a number, and that tells us the number of copies of this particular element. So if we have, for example, H2, it means that we have 2 hydrogen atoms that are bonded together. If we have H2O, we have 2 hydrogen atoms and 1 oxygen atom all bonded together. You get the point. You know what happens if it's H2O2. Okay, so let's take a look at this table where we can apply our knowledge of the atomic symbol. Here we have helium-4 2, so again, the atomic number tells us the number of protons. To get the number of neutrons, we subtract the number of protons from the mass number, and then the electrons are usually the same as protons if there's no plus or minus charge. Taking a look at the second row, we have hydrogen that has a mass number of 2, you'll notice that there's no atomic number because we can get that from the periodic table. It's the atomic number 1, so it has 1 proton. Now I made a little mistake here. This should say 1 neutron because we need to subtract the number of protons from the mass number, and again the charge is